A power station, also referred to as a power plant and sometimes generating station or generating plant, is an industrial facility for the generation of electric power. Power stations are generally connected to an electrical grid. Many power stations contain one or more generators, a rotating machine that converts mechanical power into three-phase electric power. The relative motion between a magnetic field and a conductor creates an electric current. The energy source harnessed to turn the generator varies widely. Most power stations in the world burn fossil fuels such as coal, oil, and natural gas to generate electricity. Clean energy sources include nuclear power, and an increasing use of renewables such as solar, wind, wave, geothermal, and hydroelectric. In early 1871, Belgian inventor Zenobe Gramme invented a generator powerful enough to produce power on a commercial scale for industry. In 1878, a hydroelectric power station was designed and built by William Lord Armstrong at Craigside, England. It used water from lakes on his estate to power Siemens dynamos. The electricity supplied power to lights, heating, produced hot water, ran an elevator as well as labor-saving devices in farm buildings. In 1890, the world's first coal-fired public power station, the Edison Electric Light Station, was built in London, a project of Thomas Edison organized by Edward Johnson. A Babcock and Wilcox boiler powered a 93 kilowatt steam engine that drove a 27-ton generator. This supplied electricity to premises in the area that could be reached through the culverts of the viaduct without digging up the road, which was the monopoly of the gas companies. The customers included the City Temple and the Old Bailey. Another important customer was the telegraph office of the General Post Office. But this could not be reached through the culverts. Johnson arranged for the supply cable to be run overhead, via Holborn Tavern and Newgate. In September 1882 in New York, the Pearl Street Station was established by Edison to provide electric lighting in the lower Manhattan Island area. The station ran until destroyed by fire in 1890. The station used reciprocating steam engines to turn direct current generators. Because of the DC distribution, the service area was small, limited by voltage drop in the feeders. In 1886, George Westinghouse began building an alternating current system that used a transformer to step up voltage for long-distance transmission and then stepped it back down for indoor lighting. A more efficient and less expensive system which is similar to modern systems. The war of the currents eventually resolved in favor of AC distribution and utilization. Although some DC systems persisted to the end of the 20th century, DC systems with a service radius of a mile or so were necessarily smaller, less efficient of fuel consumption, and more labor-intensive to operate than much larger central AC generating stations. AC systems used a wide range of frequencies depending on the type of load. Lighting load using higher frequencies, and traction systems and heavy motor load systems preferring lower frequencies. The economics of central station generation improved greatly when unified light and power systems, operating at a common frequency, were developed. The same generating plant that fed large industrial loads during the day could feed commuter railway systems during rush hour and then serve lighting load in the evening, thus improving the system load factor and reducing the cost of electrical energy overall. Many exceptions existed. Generating stations were dedicated to power or light by the choice of frequency, and rotating frequency changers and rotating converters were particularly common to feed electric railway systems from the general lighting and power network. Throughout the first few decades of the 20th century, central stations became larger, using higher steam pressures to provide greater efficiency, and relying on interconnections of multiple generating stations to improve reliability and cost. High-voltage AC transmission allowed hydroelectric power to be conveniently moved from distant waterfalls to city markets. The advent of the steam turbine in central station service, around 1906, allowed great expansion of generating capacity. Generators were no longer limited by the power transmission of belts or the relatively slow speed of reciprocating engines, and could grow to enormous sizes. For example, Sebastian Ziani de Ferranti planned what would have reciprocating steam engine ever built for a proposed new central station, but scrapped the plans when turbines became available in the necessary size. Building power systems out of central stations required combinations of engineering skill and financial acumen in equal measure. Pioneers of central station generation include George Westinghouse and Samuel Insull in the United States, Ferranti and Charles Heston Mertz in UK, and many others. World electricity generation.